Welcome to the second video for the Miner Mastering Blockchain. I'm Sam, and in this video I'll explain the concepts behind mining and how consensus mechanisms like proof of work and proof of stake work within a blockchain. So a quick recap from last video. What is mining in a blockchain protocol? So miners are the ones who write the transactions in an open-based ledger. So when someone broadcasts a transaction on the blockchain, the transaction is waiting to be placed on the blockchain. All the transactions that are broadcasted are pooled together, and the miners are the ones making the blocks and putting in the transactions. So in video 1 I've told you that every block is cryptographically linked to the other blocks. So first we have to understand how this process works and how miners can make a block. So the basics is that every block contains a block number, a nonce, transactions, a previous block hash, and eventually the hash that the new block will create. So once again I've drawn a simple diagram of how the block works. So first here you see the block with the block number. I put in block 30, but it could be way more. This is the nonce, this is the transactions, this is the previous hash, and this is the hash they want to create. So how does this work? The miners can put in any transaction from the pool of broadcasted transactions into the block until the block is full. Then they include the block number and the previous hash from the previous block that was placed before. So the only things left are the nonce and the new hash that has to be created for the block. This is where proof of work and proof of stake come in. Both are different systems which have rules that miners will have to follow, and I'll start explaining proof of work first. So basically when they start making a block and they have filled up the block with transactions, they will have to find a nonce, which is a hash, which will give the end result so that the new hash that is linked up, that the complete block is contained in, the new hash has to be created in total. So when you hash all the things in the block, so that is the block number, the nonce, the transactions, and the previous hash, you will get a finally hash. So what does this mean? I'll use Bitcoin as an example to explain how a proof of work system works. So miners have to fill in a nonce, which will eventually create a new hash. Based on the difficulty that the protocol sets, this means that the hash has to fulfill a few needs. In this case of Bitcoin, I've looked it up on the Blockchain Explorer, and it's 18 zeros at the moment. So this is basically a puzzle that miners will have to solve before they can present the block they've made to the network. So the zeros that are added are added to increase difficulty of this puzzle. So when they create a block and they want to present it as a hash in total, this hash has to contain 18 zeros to be valid within the system. The protocol is designed that the average time that a block is made is around 10 minutes. So if a miner has solved the puzzle and they have found a nonce which will result in a hash with 18 zeros first and then some other numbers and letters, then the miner can broadcast this block to the network, and if approved they will claim their miner rewards, which if we think back of video 1, these are fees and the block reward, and in this case that is Bitcoin. So, but in the proof of work system, the key thing is that this isn't done solely by one miner. Basically, every miner is racing to create the next block. So out of all the miners who want to create the next block after one is done, they all try to solve the puzzle as first, so they can reap the rewards while the rest get nothing. So a proof of work system contains all the miners, and they all work simultaneously, and they are racing to solve this puzzle to present the next valid blocks, which contains transactions, which has to be validated by the blockchain, by the system. So and if it's valid, they can reap the rewards, which is why the miners are doing this in the first place. So a different system to this is proof of stake. In a proof of stake system, the basics are the same. You have to solve a puzzle, but in this case, it's not a race like proof of work, where every miner simultaneously tries to solve the puzzle first. No, in a proof of stake system, you as miner stake some coins in the protocol, which tells the system that you want to create a block. So based on how much coins you stake compared to all the other miners, we'll have a linear chance to get selected by the protocol to be selected to create the block. If then you broadcast the block to the network and it's validated, you did everything according to the rules, you will get the mining rewards. If the block isn't valid, you did something wrong or malicious, the block gets rejected by the system, and you will lose your stake that you put in first. So one of the downsides of proof of work is that everyone is trying to solve this puzzle. First, it's a race, and because they are all doing this simultaneously, people consider this as a waste of electricity and hardware costs, and they say it's a waste of resources. Proof of stake does this differently, but it has because only one miner at a time gets to make a transaction based on their selection, based on how much they stake. So proof of stake doesn't use as much resources as to secure and follow the protocol as as proof of work, but in this system they argue that it's less decentralized, because the more you stake, the more chance you have to be selected to mine the block and reap the rewards. So I hope you have now a clear overview of how a proof of stake system works and the proof of work system. And thank you for listening, and I'll see you in the next video.